Hi everyone, we're the FGV team from the Visual Data Science Lab, and this is HopViz, our visual analytics system for Mini Challenge 2. The name comes from the agent-to-agent hops we trace. HopViz reconstructs the chain of people and system events behind a suspicious said IT post, starting from a log of about 185,000 events. 4 goals. Uncover how posts get published, explore how people and agents behave, unmask the anomalous hops that carry an instruction to a public post, and measure each actor's impact to decide where to intervene. Let me walk you through the system itself, the set of coordinated panels that took us from the raw event log to the answer. This is HopViz as a whole, working from a log of 185,000 events. Every panel is linked, so selecting a post anywhere refocuses the whole workspace on its causal trace. The panels span posts, timing, and incidents up top, the chain panel in the middle, and schema, payload, choke point, and actor views along the bottom. I'll take them one at a time. The posts panel shows every public post over time, with the y-axis encoding an anomaly score. Normal posts come in pairs, a human setit_post followed by the agent-side post_setit that actually publishes it. 3 posts stand out as unpaired. The posting agent acted with no human request behind it. Those 3 are our anomalies. The timing panel tests every public post against the 5-action signature we found. Queue task, check, post, then delete the instruction file and delete the posted file. Only 3 posts match this exact structure, and all 3 pass through John Winward's posting agent, always starting from a queued instruction rather than human-written content. The incident panel places those 3 matches on a timeline. Bubble size encodes how far each one reached across the agent network before converging on Winward, 39 hops, 10 hops, and 186 hops. The most recent reported case on May 17th has by far the widest spread, which is what drew attention to it. The chain panel, the large graph in the middle, lays out a post's full history. Each row is an actor. Time runs left to right. From the selected post, it traces the most likely predecessor for each actor via timing and content links, highlighting the best supported path from the upstream agents down to Winward's posting agent and its deletions. Circle size and color encode each actor's role. The chain, in order panel on the right, is the same trace as a chronological list with exact timestamps. The 5-action signature lands at 4:21 a.m. Queue_subordinate_task, setit_post_check, Winward's anomalous setit_post, then the 2 delete_file events. It's how we confirm, event by event, that the path matches the anomalous pattern. The actor panel projects all 49 actors by their event type mix using PCA, so each actor becomes a vector of how often they perform each action. We can reproject after filtering by tag, for example restricting to virus-related events, which surfaces the 4 virus-associated agents and shows Zoe Drydock as the most active among them. The choke point panel compares each actor's system-wide betweenness against how many anomalous chains they sit on. John Winward, the red triangle, breaks the most chains despite low centrality. He's the single most effective actor to remove, though in practice cutting him would be too disruptive to the legitimate system. The payload panel explains what the posts actually contained. Ordinary blobs cluster tightly in an 18 to 28 kilobyte band. The anomalous files sit outside it. Swift ran at about 30 kilobytes, and Mellow Otter at 45, and Hidden Orca has no create_file record at all. These are raw internal text files dumped to the public platform, not authored content. The schema panel confirms it at the field level. Across all 517 posts, only 3 carry a content_source pointer, and those same 3 are the only posts missing content, poster_id, and timestamp together. That combination is the fingerprint of the anomaly, a file reference where written content should be. We present 2 examples. We start by inspecting all actors and their events. Scanning the timeline, we focus on the setit_post flagged as anomalous, identify the actor associated with it, and then remove that actor, shown here in red. Here, we inspect the event types associated with each agent and the events they performed. So what does all of this add up to? To summarize, we built a system that reconstructs these hidden chains, we found the posts are raw file dumps that bypass the normal authorization path, and we identified one clean intervention. Requiring every public post to be paired with a human-initiated request would have stopped all 3 incidents without removing a critical actor. That's HopViz. Thanks for watching. The full write-up and video are on our lab site, visualslab.com, and we're happy to take questions.